Let's go ahead and get started. Hello, everyone, and welcome. Today, I am extremely excited to be hosting Dr. Paul Gaze to discuss how Coastal Carolina University uses real-time ocean data to enhance coastal monitoring and climate resilience. As a quick housekeeping note, if you have any questions throughout this webinar, feel free to drop them into that Q&A box that you should see on the bottom of your screen. Just drop that in there and we'll be monitoring the questions throughout. Most likely we'll address them at the very end, but if something comes up along the way, please feel free to just drop that question in the moment. To introduce myself, my name is Tosca Lichtenheld, and I lead SOFAR Ocean's government business. For those of you who might be unfamiliar with SOFAR, we are an ocean tech startup on a mission to close the data gap. We are connecting the world's oceans to power a more sustainable future. SOFAR was founded by a partnership between an ocean scientist and an electrical engineer who were frustrated with how difficult it was to obtain ocean data, particularly real-time ocean data, because existing systems were extremely bulky, expensive, hard for the average ocean scientist to access. And so what they ended up doing was designing the spotter buoy, one of which you can see behind me, and I see Paul has one behind him as well, which became SOFAR's flagship product. I'm joined today by Dr. Paul Gaze, who has been working with the SOFAR spotter buoys since 2020. I actually went back and checked our records, so I think your first spotter shipped to you in 2020. And he's been using them to support a variety of extremely interesting projects, which we'll be learning more about today. Paul is the executive director of the Burroughs and Chapin Center for Marine and Wetland Studies at Coastal Carolina University. He has led a diverse array of research initiatives, including studies of coastal geologic frameworks, relative sea level and coastal response to sea level, storms and beach nourishment, coastal observing and modeling applications, and offshore wind energy resource potential. He's involved in a number of advisory committees and working groups, including the South Carolina Beachfront Management Advisory Committee, South Carolina Office of Resiliency Flood Modeling Working Group, South Carolina Governor's Floodwaters Commission, and the National Messenet Program Advisory Board. Paul, thank you so much for being here today. I'm going to turn things over to you, but just a quick reminder again for the audience, if you have any questions, please feel free to drop them into that Q&A box and we will get to them at the end. All right, Paul, over to you.
Great, Tosca. We'll see if I can load this presentation. All right, is that presenting okay?
Yes, it is.
Very well. So good afternoon, everybody, and thanks, Tosca, for the introduction there. Happy to talk about what we're doing here at Coastal Carolina, and a lot of this ties into something we call the Southeast Atlantic EcoNet. This is partnering with our colleagues at the Institute for Sensing and Embedded Network Engineering at Florida Atlantic University. Much like the story that Tosca just mentioned about SOFAR, Jason Hallstrom, our colleague down there, is the electrical computer engineer, and we're more of the applied oceanographic group. And it's been a really good partnership in marriage by finding better ways to do things and partnering with groups like SOFAR and others. Our real focus is in the coastal transition, and we rather feel this is quite critical. A lot of initiatives are really kind of traditionally marine and kind of peter out when they come to the coast, and a lot of things on the upland kind of come to the coast and peter out, and often neither group really talks to the atmospheric people in some regards, in some settings. And we're really looking at, that's where our pressures are, that's where it's so dynamic, that's where the transitions are and gradients are tremendous, and that's why the need for data and modeling on the scales to address those needs is most critical. So our overall theme of this initiative is kind of a tripartite. We've got to get better observing, integrated observing in the coastal zone and across the transitional area that feeds modeling capacities. Talk about the model system that's here as well in a bit, and that will all drive various applications. Some of them are research and basic research applications, some of them are applied research applications, some of them are just public engagement and other purposes. All of that is driving a need for improved and newer technologies, particular cheaper, quicker, faster, smaller. That's easier to deploy and to get on spatial scales. That is going to be very critical to improving the predictive capabilities and the utility of all this. So the modeling framework here developed with Xiao Bao and Len Pietrafesa. It's a fully interactively coupled ocean atmosphere hydraulic model or hydrologic model, working with some of the groundwater systems as well. That coupling and connected across the coastal zone is quite critical. A lot of the flood modeling efforts really had some challenges in how the ocean levels were being handled, driving that and vice versa, how that exchange is coming across just because things kind of evolved in different silos. As a result, the team, again, Len and Xiao here, are affiliates into the new Cooperative Institute for Research Operations in Hydrology, working towards exactly this issue of improving the flood modeling capacities. And so the model improvements they require the observations for validation and assimilation down the line.
Just quickly before you move on, are you able to switch to full screen view?
I thought I believe I am, but
Oh, we're seeing the presenter view. I don't know if you click use slideshow, if that'll go into the slideshow.
better.
Yes, perfect. Thank you.
Okay. So the critical need, and we're seeing it now, is just how different things are behaving than in the past, and particularly in the coastal zone. We've got this trend of so many people moving to the coast, so much infrastructure coming to the coast. Certainly here in South Carolina is one of the more rapidly growing areas in the nation for just population moving in here, putting more at risk in terms of people and infrastructure and economy. And the system's not behaving as it is. These were some images from previously last several months or so. These enormous rain events, these changes in the storm where you're seeing them explode to Category 5s, as they're getting close to the coast. That's not really how it had been so common in the past. So what's going on in the coastal zone is changing, and it is very, very impactful. This week, we actually had the campus closed from a storm that was coming up that just kind of grew in situ out here off our coast. And it turned out to be kind of a non-event. It was rainy and such, but just up the coast was 20 inches of rain in southern North Carolina, and 3 feet of rain and water on roadways in that area. So we were anticipating a much more rain impacted event here, and it really shifted quite a bit, and it all just formed quickly just off the coast. So this pressure, this need to look in these coastal transitions is quite dramatic. We're dealing with the offshore connection. There's enough of a challenge with observations on land and spatial densities that are necessary. In the marine environment's even worse, and certainly in the coastal environment it seems to be even worse. Some of the NOAA buoy arrays are a little further offshore. It is, as Tosca mentioned, expensive and challenging to keep gear out there. We targeted getting instrumentation out there in what we call the Smart Reef initiative, where we're locating gear at artificial reefs in the state. Some of that is a very practical matter. The artificial reefs have a blanket permit through the South Carolina DNR, and so we're able to install gear without quite as long of a challenge getting permitting and all that in place to do it, particularly if we're trying to sustain that. So we built it around the idea of targeting these reefs, and there's a number of them up and down the coast, and many of them are inshore and they span across the shelf. The other part of that is while we're out there building material and putting material in at reefs, we figured we might as well try to make these reefs look like the natural reefs. Typically, these might be cement cones that have been developed, or subway cars or shipwrecks, things like that would be put out there. We're looking at, can we build the reef material that become the infrastructure for the observing system that telemetry's on out, and the problems and challenges that this works for, waves and currents and coastal erosion and hypoxic issues, which we have off the coast here, looking at it as an integrated system, as well as for public interest and university benefits for education and research. So this first initiative, first stage, we looked to make this simpler, smaller. We had an engineering student or class come up with small modular blocks that we could put out that wasn't going to take a big ship. use the spotter as obviously the wave sensor, but also then become the core for tagging on other instrumentation. And as we start to move towards this more integrated system, that's what it looked like. We started playing around with 3D cement printing to make these reefs look like our natural reefs, and that seemed to be far more involved than we had the time for. At the moment, we're working on using a low voltage current to drive calcium carbonate precipitation. It's often referred to as biorock kind of process. It's used for coral restoration initiatives. But precipitation of carbonate straight from seawater to become the infrastructure of the reef, so we can make it emulate the reef, and then it becomes a structure to put instrumentation on for how that goes. So that's the present stage that we're at. And again, using the spotter as that kind of backbone. With that in place, there's a communications piece to it. This idea of something similar to what Bob Ballard did after Titanic was the Jason project, where they could connect in educational involvement on the other side of the planet. We're into a classroom and people would be part of the cruises that Bob was doing in those days. And do that in the coastal zone where data's telemetering in, 24/7. It's available. That can be brought into classrooms and things like that. And get out on site on a boat, drop an ROV down, sonars, all that. That's kind of an engagement or extension component of it. So that's kind of one of the goals. So there's just some data that was spots along the coast here. This is South Carolina DNR's vessel putting in a spotter, and some other blocks contributed to the reef system on the bottom. We had these arrayed along the coast for a while. Just an example of data. In this case, we caught one of the hurricanes that came by and happened to have a pressure transducer on there. The idea of looking at the surge as it evolves offshore. We typically track that and validate it along the coast by water level marks on buildings and whatnot. Buoys sometimes don't survive the storms and such, the traditional buoys, and this rode it out. The little guy was out there for quite a number of storms. We were quite happy with it in that regard, but just other kinds of data that is being added into it. I mentioned the present application with this biorock kind of process. We're working in the off of Parris Island Marine Corps base. That probably is on a timer, that one. See if I may have to just drop out of this for a moment because that slide's wanting to advance. Can you live with this slide for just a second?
Yeah, absolutely.
Okay, so we'll transfer on us. There's a serious erosional problem there in Port Royal Sound. These are an area with about a 9-foot to 12-foot tidal range. And marsh has been stripped away. There's an artificial reef just off the coast. And the idea is, what can we do in the artificial reef idea? Moving material around to modify processes to take some of the pressure off of the erosional challenges that they're having. Again, the marsh is gone, that functionality or those ecosystem services are gone. And so one of the things that's happening is the base there had hundreds of these concrete transportation barriers you might have on a highway. And rather than go to the landfill, we can contribute them to the reef, build this other structure and try to drive the precipitation from it. It's a company called Nexmar out of Maine that has a hydrokinetic turbine that we're going to test out here later this fall to drive this precipitation and then move these into the near shore as sort of living shoreline structures, at least the start of them. This is a beneficial use of all this concrete material. But they all serve as an infrastructure to put instrumentation on it, whether they're tethered to a buoy or surrounding information that may log into that or connect into that and on out. So we are slowly adding in things through the Bristlemouth connectors that have been developed, and that's our goal. And we're just building on that on a regular basis. So we see this as a critical need for increasing spatial density of diverse observations, integrated observations, multidisciplinary kinds of approach. You got the infrastructure, might as well leverage it and put as much in. That's kind of how the funding works. We've got funding from a number of different agencies, but no one is really putting it together across the coastal zone. One's looking at the atmospherics, one's looking at the ocean, some are looking at flooding. So we're really kind of leveraging and stitching that all together with a wide array of of funding that we're finding pretty good success keeping it going. Sustaining something is always a challenge. This makes it a little easier financially. There's been a lot of historical and logistical challenges to make this transition across the coastal zone, larger buoy systems, larger ships. Just the challenge and cost of doing that was really limiting. And there's a wide range of interest along the coast that are helping with some of the enduring this. There's a range of stakeholders at the state level, at the local level. And we find everyone coming together with a little skin in the game, even nonprofit groups that are looking at ecotourism and things like that. When we put the buoy in off of Hilton Head, Beaufort area a couple of years back, I must have got 20 emails that night from people in the community. And again, because I've been out there too, when the forecast was light and variable and getting the living gajibers kicked out of us when it was not light and variable, they were very interested in getting that nearshore data and an active. So even that kind of engagement to the public has been rather beneficial. And as a result, they tend to be very supportive of the program and facilitate and help as they can. And it's a good partnership when we do that. So looking at these technological and operational advancements to again expand that spatial density and sustain the initiative long term, and then building into that this opportunity to improve the public dialogue and a more complete systems-oriented public engagement about environmental challenges in the coastal zone. We have plenty of them. They're not going away. They're getting more impressive and more challenging, and they need and demand innovation and strategies to deal with the rates of sea level rise and the changes in the storms and whatnot. So we're hopeful that by this strategy and pulling this together, we can make some positive contribution to those efforts here. And lastly, this is what we're doing here at Coastal Carolina. Again, our partners key, our Florida Atlantic University, Jason Halsom's group, but there's quite a large number of partners, counties and state agencies and nonprofits and private sector. It's quite an elaborate group that's come together from here to Florida now as this is expanding out. But any kind of questions, happy to answer. There's a contact number here, give you some idea of what we're doing here at Coastal Carolina.
Awesome. Thank you so much, Paul. For everyone in the audience, please drop your questions for Paul into that Q&A box. But I'll kick things off. Paul, you talked quite a bit about spatial density. What kind of demand for specific parameters are you seeing from the community? Like, what do they care about the most? Is it the waves? Is it the sea levels? Is it the water quality? Is it a combination of it? And how are you partnering with those community groups?
Well, I think the primary demand at the moment is in the flooding side of the house. So it's up in the watershed in the basins there. And so those are, relatively inexpensive water level sensors. That's a NOAA funded, started with National Science Foundation funding. Duke Energy's been supportive in advancing it. The state here in South Carolina and Florida is expanding out these water level sensors. It's surprising, and I suppose it shouldn't be surprising how variable those levels are in the coastal zone and just over a kilometer, just wind blowing one way and rivers and creeks coming together. And we've had such enormous flooding that's a driver. And ultimately, it's tying to the coast, and that water level down at the coast and how that propagates up through the estuary is influencing further on up the basin. So that density drops off, but our density normally along the coastal zone is pretty thin. Our federal buoys are like 40 miles southeast of Charleston, out there off of Frying Pan Shoals. They're offshore. There's a couple inshore buoys. UNCW's got some things inshore in North Carolina towards the border. But after that, it's slim pickings, and it's not there long term. It kind of comes and goes, and that transition. So those are the areas where things are exploding now. And it's just the posse data. Some things you can do with satellite. So the ultimate density is at this point, we're distributing things kind of as we can around artificial reefs where we can pull demand and resources together. So they're getting spread out and that transition into the coast. So we're putting some buoys in the estuaries. Certainly there's a difference in what we're doing with that. Some of these are erosional sites in estuaries, and you're trying to extract out swell or basically the wakes from boats is the challenge for some of these, and the routine for extracting that out has been a good starting point that Spotter has developed. And so that goes. But if you have an infrastructure, then to build around that, right now you might have everything on one site. The ultimate goal is then to be able to telemetry things in from a kilometer around the reef, because it's the variability in that scale. Acoustic modems are expensive, all of that. So figuring out how to start bridging that out spatially and look at that heterogeneity. We do a lot of that with geophysical techniques, a lot of side scan and 3D sonars and other kinds of things. We're not into drifters or drone or AUVs yet, but that's a good way to connect between these site-specific areas.
That's a perfect segue into a question that we just received, which is what kinds of enabling technologies are you looking at? Either that you are in the process of incorporating into the EcoNet right now and the smart reefs, or that you're looking at for the future?
So a lot that are getting brought in right now. We're adding in just passive acoustic tags for fish tags, pins for fish. Our biologist colleagues and the state agencies are doing a lot of tracking in that regard. So we have an infrastructure out there. It means the telemetry has considerable benefit. There's water quality sensors and pick up things like chlorophyll and other nutrient signals that can be built in. Some of those become a little challenging in the maintenance. Some of the optical sensors, you got 10 days, in the summertime. The biofouling is quite intense. So that still is pretty intensive. But if that can be done with diver operations, that doesn't require, a giant ship, that also partnering with groups like local dive shops, and many of them, students are already working for these people, can go out and do a basic routine. You get them trained up to do that reasonably well. Might be able to sustain things at more places longer. It ultimately comes down to many people that you need to keep different sensors out there.
Definitely. And so that actually leads into another question we got from the audience, which is how can someone who is interested get involved locally? And then also people who might be on the other side of the country, are there things that those people can do to get involved?
Yeah. So firstly, we go to this Jason analogy that what Ballard did. We're trying to build this out. We've received calls from high schools from Virginia to Georgia that looking at connecting into this stuff. So there's this live feed all the time. We're very much thinking that is data that, let's say, whatever class they may be using can use it. People that are public interest. A lot of the people here, we had some interesting engagement from the public with our water quality lab. They first found hypoxic pressures here. And then the way they found it is it was referred to as the flounder jubilee. There was this flounder being caught left and right on the piers, and everyone was happy. In reality, that was an oxygen problem. And so it was a challenge. And so that became an issue. So you'll see now people talking, on the piers fishing, talking about the DO levels, which is, a different kind of experience. So that's really what we're hoping to do besides the basic and applied research, is engage people and really try to raise the playing field in terms of the complexity of this coastal system, because we're having to deal with it as a community. It's not science, it's not business, it's not all these different aspects of everybody's got to come together and change how we're doing it if we're going to continue to manage these things, if not optimally, at least manageably in the near future. Getting involved locally in this area, we have a workshop going on in November. We're physically working with communities like North Myrtle Beach here. The university has a property called Wade's Island. It's an undeveloped island at the border. We have about a third of that property. The state, led by the governor, is trying to conserve the rest of that property. We're getting very close to seeing it all. It'd be 3,300 acres undeveloped at the border. And so there's a community there that we've worked with for decades about how do we come out there, give them tours. There's archaeological sites out there. There's historical sites out there. There's all this environment. So people, the environment, the economy has always been interweaved. That's kind of the mission. So we're having these now chats, since we're going to be seeing the university facility being out there now, a more substantial facility. What can we do with that can bring more people through? We can't bring tons of people through. We're still trying to conserve that area, but how can we be more impactful in terms of the value of that to this public dialogue, both by stimulating discussion remotely from data and streaming online when they're out there in a boat, they can connect in, et cetera. So that's all working through. But then when they get on site and come in, they're already kind of spun up and can be focusing on some conversations and more specific workshop. So we'll see that kind of thing spin out locally. But I think nationally, there's so many observing systems out there, and what people could tie together. It's kind of what their interests are, I suppose. If it's the general public, the science, community is always good at contacting and connecting in, and given a few minutes, I think people come up with good ideas and generate some proposals, and there you go. Sometimes it works. So that's a possibility as well.
Yeah, absolutely. And I know you're also involved with the National Mesonet program, and that's an example of there's all these different clusters of observation networks all over the country, but then they collaborate to all share their data with NOAA, which is really cool.
And that's a great example because the Mesonet is on land, right? And that's a NOAA function. And then you've got the IUCE, which is offshore. And we're kind of funded through both sides. And but our mission is to cross over. So we start drifting those missions or those traditional approaches, blending that line a bit by virtue of working with both. And both are trying to do that. I mean, we talked at the Mesonet meeting this year, and the importance to coastal states of bringing more ocean information in, and then other meetings to talk the other way. So we are starting to see that bridge across the coastal zone, and we're really glad to be part of that, and hopefully just facilitating it along.
Definitely. So we have another a little bit unrelated question, asking about how much baseline data did you collect versus post-intervention? In this case, I think intervention referring to the Smart Reef data did you collect, and were you able to measure the efficacy of the reef environment? And how did you decide the density of sensors that you deployed?
Well, at the moment, the base configuration is a spotter as the conduit for other sensors that come out. There's no single funding source for Smart Reef. It's what we're piecing together. So it's not optimal. I think the previous slide talked about compromises. It's not necessarily we can then field this for next 20 years as an integrated system. We're leveraging various things so that the overall design may ebb and flow a bit, as does the number of sensors get distributed as projects come and go. There's a present focus now down in this area in near Beaufort, South Carolina, with these resources coming in. We've had a focus in Winyah Bay, in the upper Winyah Bay, and so things were pushed up that way, and that takes away from these other configurations. So I wouldn't say that we've got a network of these that have dozens and dozens of sensors. That's the goal and the vision. I think we'll be able to maintain one of those in a substantial array of diverse sensors right off the coast, because we're here and our boats can get out there and whatnot. The further afield, that becomes more tenuous to sustain, particularly regularly. But one way to solve that is to make friends. So some of these efforts, I've got my group, my team is down in Beaufort now on part of this project. And there's a USC, University of South Carolina, Beaufort campus right there. So we're starting to partner with those guys. Their students and faculty can access the data. We can pass some funds, and it's a 4-hour drive for us. It's, a 40, 10-minute drive perhaps for those guys. And they're bringing expertise we don't have, and we can part. So I think that networking capacity in that regard has some potential. Looking at bringing in like dive shops that can come out and do some basic things. We've even had some conversations with ecotourism boats that are going to come out, and they know wind farms are in the discussion for offshore, what that might look like. If they're going to be going by all the time, let's put sensors on them and get some Lagrangian, daily transect kind of deals. But if they have mechanisms such as divers get down the bottom and can bring in the citizen science kind of component to that, that's another significant resource. But to date, we don't have one funding source that stitches everything together in an optimal design. So it's a little more patchwork. It's certainly where we're trying to go to, see if we can pull enough funding. A lot of this is pulling sensors from previous grants and projects. I mean, none of it's specifically for that focus. So, some NSF grant ends and we got a ton of gear, we're putting it out. Some things are coming in from communities that are interested. They want to say have wave data off the coast and are willing to partner it, at least for the telemetry cost or something like that. So a lot of the time, I think we'll be networking and building out what diverse groups want. And so there's more compromise. There's a science objective or maybe different objective of these teams. So what comes out of the mix of that is probably quite productive, but it may not be optimal for any one of them.
Yeah. So we got a question about what data the spotters collect. So I can answer that part, but then Paul, I'll let you chime in what other sensors you're adding to your spotters. So the SOFAR spotter buoy, just the top portion, it's solar powered, it's satellite and cellular connected. So that's how the data is being transmitted. And it collects real-time wave, including wave spectra data, wind, sea surface temperature, and barometric pressure. So you're getting both like the ocean side and the atmospheric side. But then we also have a smart mooring attachment that you can connect subsurface. And there's a number of different out of the box sensors that you can add on to that, like a subsurface current meter, a water level measuring node, which is based on a bottom mounted pressure sensor. We also have inline temperature sensor nodes. And Paul, you've been using our dev kit capability, which enables anyone else to add their own sensors. And so what type of sensors have you been adding onto your systems?
And that's been the goal. I mean, there's off the shelf that worked with Spotter early on. They had company that had, we already had these sensors. I'm not going to spend, 20 grand a pop for 20 of these things. We have them here. Let's see if we can. So they developed a capacity to connect in. And it is evolving along. It's not entirely turnkey. It's as people come on and set up the code, then it'll be turnkey. But the first one you put on it takes a little bit of doing, and they've been great to work with in doing that. So what we've added on has been XO2 water quality sondes, and that's piping in. We're in the throes of trying to bring in these acoustic fish tag receivers. That'll be coming up in the near future. We've bundled in and did purchase this directly into the system, was a point along the line mooring current meter, and have an ADCP nearby to kind of overlap those for a while. It'll be way easier to maintain that spotter current meter than an ADCP. With ADCP be great, but it is really painful and expensive, and we'll make that adjustment. So
How
that's
impactful is the real-time nature of the data as well? Because the ADCP is usually not transmitting in real time, whereas the spotter current meter is giving you the currents in real
well,
time.
it can. It's just really expensive. I mean, like very expensive. You can have 10 spotters, or not 10 spotters. You can have a number of spotters for the cost of doing that. Well, it's close to that. I mean, you're going to have it's pretty pricey with the NEMO and the conversion and then the satellite connection and all. That's a major undertaking. We've done it. We've got 6 traditional 2-meter buoys. We can't sustain those. And we can sustain spotters and proliferate them, frankly, at some pace. We're really interested in things that could potentially down the line be live video feeds. Depends on the bandwidth and the communications that could be close to the coast. Maybe it's conceivable. That's something that is in the near term. We've been playing around with can we maintain a fishery sonar at depth? Because we're building around reefs, our visibility is not very good. We're not going to get very far with that. So the possibility of setting up a system that can be mounted at depth and operate around these reef structures. A lot of that's going to get driven by what science can be done. Some of it's student interest, but faculty and collaborator interest that want to really partner and build off of the other data sets and bring something to contribute to it that leverage those data sets, and really happy to work with people like that that can identify. We can put gear out to measure things if it's not going to get fully utilized. It's not as much of a priority, but somebody really is going to do good things with it. That's all the better.
You mentioned wanting to monitor like the fish, and is there a specific acoustic receiver you're looking at to integrate into the smart mooring, or what's your plan on that side?
We've had some here as faculty and have worked with a gear, and the state DNR has one. There's Innovacy out of Nova Scotia. We've got some of those that are just deployable and they're not real time. So the interest is we have the infrastructure. Let's get ones that are real time feed and then run it through the system. Otherwise, they're out there for 3 months or whatever it might be. The prospect of missing an event. I don't know how we're going to handle that data publicly, to be honest. That might be a challenge. We'll have to have some conversation about Hey, there's a whole lot of fish here today. That may not be something that
Everyone goes racing out.
yeah, you destroy what you are trying to conserve. But those are ethical questions we'll have to have with the agencies and
Yeah.
such.
We got a question about how you see a role for autonomy in these programs, either that you're using right now, any autonomous systems, or how you see autonomy playing a role in the future. And I'll tag my own question onto this, which is how much of the data that you're collecting is going into models or being used for prediction?
So one of the early frameworks of the concept was these distributed sites. Once we started getting like basic data, and there was this enormous interest, some from let's call philanthropic organizations, some from just communities. How quickly can you put 100 of these things out there? Well, we can't do that quickly, and we can't handle that. Even if you wanted to fund it, we can't do that. But we can start building partnerships up and down the coast where well, we're not running down to Florida. You work with Jason and those groups. So I think some time spent in that. We talked about some critical mass of structures. Some of them are going to be dictated by what the science questions are. Some of them are to get a reasonable geographic coverage. But if you could then start connecting between point data that's continuous in these Lagrangian paths between would seem to be quite valuable. We had a conversation earlier this morning, and we're going to put this hydrokinetic turbine out and other power connections. Could you have autonomous vehicles connect in and charge or deep charge or something like that? Certainly as wind farms and things like that come along, people are talking about that kind of thing. There might be an opportunity for that. But I think that's a way to start bridging between those as our vessels that are going by those places all the time. Like I said, we've got ships or boats that are coming out of these local ports that go right by here out to the Gulf Stream every day. There's no way I can get a grant that will do that for 10 years. It's not going to happen. And I think it's that time series that's critical. On the science side, it's really tough to get monitoring guns. It's not funded. But if we want to get beyond seasonality and a year or two, interannual and decadal, which is where the changes are really most striking, it's about the time period we can respond to, as a society. That's the critical, focus to start getting those kinds of, we don't have many of them. So starting to get there. Be great if we could get a community together and fully set up a whole Christmas tree of things. But I think it will be piecemealed in the near term to do that.
Yeah, and just to follow up on that, is any of this data already being used in models? You talked about like the density that's necessary to do some of the predictive work. Is it already being implemented?
Yeah, internally. So as you know, National Mesonet is looking at, it pulls in non-federal assets. So they're doing a pilot with, so far this last year or two, to be able to bring in the data into the Mesonet program, which goes into the forecast models on a frequent basis. Our onshore stations are every 5 minutes that go in, and it's a much higher density, but there's so little data out there that's critical. So we're only hoping that becomes, you may know before I do, that it's accepted and they'll be able to bring that in, because there's a lot of spotter buoys out there. But that's a parameter then that comes in. We've been talking about how do you get precipitation at these sites, because even on buoys, it's tough. And so we've been playing around with the acoustics. Can you pull that out from the frequency of rain noise versus wave noise and all that? It's not going to be perfect, but absent of anything, and it can be spatially distributed. We think there's great benefit in that. Our modeling focus here again has been really kind of targeted to flooding. And tropical flooding, and that group's again led by Xiao and Len. There's been some PhD students that have been adding to the modeling capacity, and the number of sites that are out there is a data point. It's not enormous, so it's used, but it's not changing the world by having enough to do that yet. But it is getting informative. They've been playing
Yeah.
around with what drifting data can do and things like that as well.
Yeah, and hopefully setting a good precedent for other communities that might have issues with coastal flooding about how they can use this data effectively.
Yeah, I think that connection to the near coastal flooding into the even the mid into the coastal plain. It's a huge problem, and we've got flood warnings again here today. We've had them some very serious events inland here, but it's all being driven from the coast. Primarily, that's where the storm's coming from, the water's coming from. So I think that will be beneficial. Would it be the same density offshore? Probably not. Um, but the Nyquist or the sensitive spacing, I don't think we've got a feel for that yet.
We have one more audience question around wave energy converters. Have you been using any wave energy converters? You mentioned a hydrokinetic turbine, and are you looking at any kind of energy side of things, or are you mostly focused on the observation collection side of things?
We are. We've done a lot with wind here. And many years back, that's what we had the 6 traditional 2-meter buoys arrays out to 12 miles. We were looking at that gradient in the wind picking up versus the distance from coast and the cost and all that. The wind resources are sufficient here. The waves and the tides were not at the time. The technology is probably 10 years ago or so. We're just not going to be productive. Could they be co-production? Quite potentially. The hydrokinetics probably going to be productive in this test down the south end of the state. It will not probably hit the nameplate production on those. And so the cost, but these are not crazy expensive devices. How that goes. Waves here, if anyone's asking that question, they're going to the Outer Banks to surf. They're not coming to Myrtle Beach to surf. We just don't have that kind of wave field unless they become super efficient with small waves. We might see some currents in local areas. We had current meters up and down Winyah Bay, which is a pretty good current, but it wasn't sufficient really for the turbines of the time. But that's the hope. All the above, take some of the pressure off would really a goal.
Yeah. All right. One last question. We actually just got this one, which I think is a really great note to end on, actually. In terms of achieving wider coverage, are there any future plans to develop virtual buoys? So being able to extract wave parameters using other data sources and create a virtual buoy.
We've not explored that terribly much. There's other technologies, things that might be done from satellite platforms as well. But then within the models, can you set up something and validate it? That would be a great thing to try to develop, but we've not done that yet.
Mm-hmm. Cool. Well, thank you so much, Paul. We're coming up on time. Any last thoughts for the audience before we wrap up?
No, it's just that I do think this is really quite critical to deal with this coastal transition and the nature of getting instrumentation cheaper. It may not be 100%, it's 97%, but if you got 90%, 7% distributed spatially meaningfully, that will be very helpful. The heterogeneity in the coast is unreal. And the models have to get much higher resolution. They've got to have data to drive them on that. So the bulk has been, the traditional flood and weather and surge kind of thing. And then hopefully we can get more and more capable. We're hopeful to see some of that, particularly with the hypoxic question here, getting data. There's lots of sensors on the piers for DO and things like that. But as you get in the coastal ocean and there's been some tracking isotopically, it's not that straightforward what's triggering that stuff and how to manage it. So we think having these stations out there, even if they're widely spread, is getting data that we don't have to start constraining how to deal with that issue.
And that's a great segue for me to talk about. So far, we're working on a DO sensor integration as well for smart mooring. So soon that will be something that we'll have available.
I seriously suggest you put in or consider groundwater radon, other isotopic sensing for submarine groundwater exchange. because it is a big deal. It's a big deal here, but it's even fewer data sets. There's a couple, and it's when you see it, it's quite interesting how impactful it is.
Well, thank you so much again, Paul. For everyone who's still online, we will be sending out a recording of this webinar. So look for that in your email in case you want to go back and reference it. Paul also shared his contact information on that slide. So if you have questions for him, you'll be able to follow up with him offline. And so with that, we'll wrap things up. Thank you so much, everyone.
Sounds good. Take care, everybody.